Hey everybody, welcome back. So this is a all reading one. So if you don't want to watch me read this, then feel free to just read it yourself, and we can move on to the next one. Introduction. To really understand how Rails work, you need to have a solid base in the guts of the web. You've already covered some of it in previous sections, and if you went through the Ruby curriculum, you can just skim it. But this time, you'll get a chance in the project to reach out and make some real web requests. By the end of this lesson, you should be able to do the following. Explain basics of HTTP, identify 4 commonly used hypertext transfer protocol verbs, identify 7 RESTful routes for Rails, name the different components of a URL, explain the basics of the MVC or Model View Controller, describe what an API is or an application programming interface, explain what cookies and sessions are, describe the difference between authentication and authorization. HTTP is just a way of structuring a request and response conversation between your browser and the server. Actually, it's not even a conversation since it's stateless. It's more of an ask and receive. The protocol outlines how the brief piece of dialogue should occur. Check this Toots Plus post on HTTP, which describes what's going on in the HTTP. Check out the test URA sniffer to try to receive a couple of websites, like the Odin project, on your own. Check out this great video on communications between HTTP requests and web servers. Watch the tutorial. Learn. Watch the full course. Okay, cool. One key component to pay attention to is the fact that the request and response both have header and usually body components. The header contains information about the request or response itself or its metadata, including which website to send and return and to what status the response is. The body of the request can contain things like data submitted from the form or cookies or authentication tokens, while the response will usually contain the HTML page you're trying to access. The other key component is that each request uses one of the 4 main verbs: get, post, put, and delete. These days you almost only see get and post requests. Even if you're trying to delete something, they usually fake it using a post request. But it's important to understand the difference between the verbs. REST, short for representational state transfer, is a term that you will see coming up again and again because it's a very powerful idea. It basically says that there are only 7 different types of things that you usually want to do to an individual resource via the web, and you can do them by mixing and matching the HTTP verbs we just covered. A resource usually means a thing in your database or a data model. In this case, we'll assume that that resource is a blog post model that you'll set up. So get all the posts, aka index the posts. Get just one specific post, aka show that post. Get the page that lets you create a new post, or aka get a new post page. Post the data just filled to the server so it can create the post. Get the page that lets you edit an existing post, aka view the edit page. Put or patch, which are the same, I think, the data you just filled out for editing and the post to the server so it can actually perform the update, aka the update the post. Delete one specific post by sending a delete request to the server, aka a destroy the post. The highlighted words correspond to the standard Rails controller actions. Oh, the highlighted ones. Interesting. Update, create. Oh yeah, this show, index, show, new, create, edit, update, and destroy. These highlighted words correspond to standard Rails controller actions. Yeah, agreed. Why is this important? Because it gives you a very organized way. I'll just keep that up there. Gives you a very organized way of thinking about your resources. This is the way to model your request and should be the only way that those requests are done. E.g., you shouldn't be actually submitting the data from editing a post using a GET request. This should be a post. If you have a hard time thinking of how those 7 scenarios, or at least a subset of them, would apply to a resource you want to create in your database, you may need to rethink how your data is being set up. This all makes a lot of sense if you have experience with this, but if not, I would imagine that's very confusing. It's also important because Rails is structured to follow these conventions in a very straightforward way. As long as you're performing those actions, life is very easy for you, and the request that you get from the browser can be easily routed through the Rails guts. It may seem simplistic to you, but upfront, to think of things this way, but once you've got a bit of complexity in your data model, you'll find that falling back on restful thinking can help you untangle things for you. URLs. You may think you know what's in a URL, but which part is the host? Protocol, aka scheme, parameters, and path. Check out this article by Matt Cutts on how Google picks apart URL components. We're not going to try to rabbit hole into these side projects. Quick quiz. The URL says, what is the path? I think Google is the path. What is the parameter? Q equals this one is the parameter. The top level domain? Oh, Google. The path is probably .com. Top level domain. Oh, TLD is the .com. Protocol, HTTPS. So maybe Once you understand this, answers 1 is the / search. Oh, the path is search. Okay. 2, the parameter, Q. This one, the parameter. 3, what is the top level domain? Com, I think I got that. And then 4, HTTPS, I think I got that. Cool. MVC. You've heard about it again and again, but what does it really mean? MVC. MVC is all about organization, and Rails is all about MVC. When you build a new Rails project, you get a giant mass of folders and files created. Though it seems like there is an overwhelming number of files inside your app directory, they are highly organized and specifically meant to separate the model, view, and the controller. The point of MVC is that the functions of a web application can be broken down into more or less indistinct parts. I'm just going to show that real quick with our project that we set up. We'll just open this up real quick. Well, let's do it with the terminal. Let's change directories into desktop. List this out. Let's change directory in Odin project. List that out. Change directories in my first, and then go code dot. Cool. I'm just going to explain what they just talked about here a little bit. If we look at the folder structure here, we see here they say in your app directory, right? In your app directory, you have assets, channels, controllers, helpers, JavaScripts, jobs, mailers, models, and views. So it seems like there's a lot in here, but each of these are really valuable. So that's what they're saying then here. So the point of the MVC is that functions of a web application can be broken down into more or less distinct parts. Even each part gets its own Ruby class. That's great for you as a developer because you want to tweak a specific part of a code base or to fix a bug. You know exactly where to modify it. If you've got a view control problem, you can go to your view and check out your cars, and you'll be able to see your form. If you have something's going wrong with your API, you'll probably want to check your controllers first, or maybe your routes. The path through MVC. Once a request from a browser comes into your application, at the most basic level, the router figures out where the controller is to send it. So if you go here, route, the router decides where to go it. So it comes into the application, it comes to this, and then that sends it to our controllers with a method, right? And so it's going to send us to the cars controller, which is the index method here. So here we are back in the app folder. And then the controller says this guy. This is calling the car method. And so what we would want to see is we can go car. And if we put model in there, it'll show us here. And so this is where we instantiate car. Or we define car in the application record, right? And that's being sent to the application controller, which is being sent to the Rails application routes. Or it's backwards though. The controller passes off whatever data it needs to the views. Cool. So the controller comes back, and the controller, like it's set up here, where our GET request is passed to the index. That controller, it goes to the views, which is down here. And so in the views, we have our index. So our cars and our index. And so this is what the HTML here, or this is ERB, to render the page. Once the proper view has been pumped full of data, so it's saying cars.each, so it's taking all those cars. And where is it getting that instance variable? Cars, it's getting it from the model. It gets sent back to the and presto. Check out a more detailed version here. To To characterize the three badly, the model is the supermarket geek in the back room. The controller is the social middleman that talks to everyone but doesn't really do anything too intensive. It asks the model for those cases. And the view just looks pretty and waits to get its outfit from the controller. Just roll with it. You'll see it in action. API. Okay, so I'm just going to maximize this so we see this. API. When your computer or a server, which you're programming, wants to make a request to another website, it doesn't bother clicking on things in the browser. It asks that other website for data directly by using the website's API. An API is just an interface. Our web browser goes in the front door to display a bunch of info from Facebook. Our web server goes in the side door from the same data. Much faster and more direct than the API. So you want to get data from Google Maps to display on your web page. You hit an API using the rules specified in its API documentation. Just about every big website makes some portion of its data available via an API. You can too quite easily using Rails. You can too quite easily using Rails. See this explanation. We're going to skip that for now. How stuff works. If you're going through this on your own, I really recommend checking these things out. This is just kind of, I think it's just a little too tedious for me to go through this right now. These kinds of things, how web servers work, I think we've done that in the fundamentals, so we're just going to keep moving on. Not all APIs are web-based. Plenty of them use the same HTTP format, but are really just designed to pass data between services. In fact, that's how the components of Rails are all strung together. They use HTTP to communicate with each other. You'll actually get a chance to build your own API a little later on. The Rails makes it really easy for you. There's nothing magical about it. You just tell your controller that you want to respond to a request made by other servers instead of a normal web request, and then specify what exactly you'd like returned, since it probably won't be HTML view. It won't be an HTML view probably if you're doing APIs. But we get ahead of ourselves a bit here. The main point is that you'll see an API come up plenty of times, and it's totally harmless and just means the way that two applications talk to each other. Yeah, API, application programming interface. You have one API talk to another API. It's just having computers talk to each other. Cookies. You've heard about cookies. Cookies are basically a way for websites to remember who you are and from one request to another. You can actually check your cookies here. You'll see this is the Odin project cookies. And they'll be able to tell you this might be some secret information. Somebody might be able to log into my computer if they saw that. But I don't know, sure. Or my Odin project, but that would be kind of useless. Completely new user. Unless they've given you some cookie, which they most certainly have. Cookies are little bits of data that your browser sends to the website every time you make a request to it. From the perspective of the web server, it lets the server identify you as the same person who made any series of previous requests. It preserves the state of your session. Check the All About Cookies here and the Wikipedia article on cookies. I'm actually kind of interested on these. You're serious about securities. Let me see about that. Would that actually show my thing? You see, YouTube loaded a cookie in from me loading this page. So there's probably some sort of a YouTube cookie thing here. Cookies. Sessions. Those are the kinds of things. That website had already loaded cookies. Let's see what cookies Wikipedia uses. So yeah, see, so Wikipedia has cookies as well, even though I'm not logged in. It's probably a geolocation thing, a geo IP thing. I think I'm in Reno. Okay, we're not going to read that now. Go to the website you normally frequent, open your developer tools, and find the cookies. So in Chrome, you can say inspect application cookies. So you could go applications, cookies. Here we go, cookies. And that'll give you the Odin project cookies. Oh, cool, it's a ... so there's not showing the whole thing. Often there will be something like user session or token, unintelligible string of characters. Sessions. Cookies are important because they enable you to have a single continuous session while you're interacting with a website. It means you only have to log in once instead of every single request, which you'll probably experience with a broken website at some point in the 90s. Your browser includes all the cookies that a particular website has set along with its normal requests, and the server uses those strings to figure out which user you are and whether you've logged in. What your settings are, like if you've set up viewing preferences and things like that. Yeah, the Odin project's black for me because I set that in there, and so my cookie tells the Odin project who I am, and then the Odin project uses that cookie to fetch the data that has associated with me. It's also why when you clear cookies from your browser history, everything seems to get wiped out and go to default. So if I were to open a new project and go to the Odin project by pressing Command-Shift-N, it gives me an empty page without any information, and it wants me to log in. It's also how some ads seem to follow you from one website to another. We name this tracking cookies. So yeah, that's how Google tracks people. Authentication. On the server side, you'll interact with cookies and session variables quite a bit. As mentioned above, one of the main uses of these is to determine who the user is, or authentication. You'll basically retrieve the cookie that the user sends to you. Use it to find the user in your database, and if the user exists, you can display the customized web page for that user. Cool, that's what I just said. It's pretty straightforward in theory, but some of the security implications get a little bit hairy. So luckily, the nice folks at Platformic created a very handy gem called Devise, which takes care of all this stuff for you. Yes. In the curriculum, a bit later on, you'll be creating your own authentication system before learning how to use Devise to take care of the heavy lifting. Devise is great. Authorization is a partner concept to authentication. Authentication lets you determine who the user is, but the idea behind authorization is that you might limit what the person can see based on the permission level. The most common case of this is actually the distinction between a random, not logged in user and one who is logged in. Another common case of this is the difference between regular users of a website and the admin users who have special privileges. On the server side, you will end up writing or using methods which restrict access to certain types of actions based on who the current user is or whether the requester is logged in at all. Again, Devise will help you with this by providing some of these helper methods, like for checking whether any user is logged in or who the current user is for you. Absolutely. Conclusion. We'll dig into this stuff a bit later, but it's good to understand in the context of what we've talked about before in regards to how requests are made, because it brings a couple of extra layers onto the formerly independent HTTP request. Authentication systems allow you to establish sessions which preserve the user's state, like logged in status, across requests, and helps you determine whether the user is authorized to do a particular thing. Additional resources. This section contains helpful links to other content. It isn't required, so consider it supplemental. I'm going to consider this supplemental for the purposes of this video. And knowledge check. What do you call HTTP message that goes from client to a server? What do you call an HTTP message? It's a HTTP request? I don't even know the answer to that. Did I just read it? Proof of everybody what's done. HTTP is a hypertext. It's a request model, a request response model. Is that what they want? Verbs, put, delete, cache control. It goes in way detail. I don't want to go through that right now. The Odin project. What do you call an H that goes from client to server? A request. What do you call an H message that goes from a server to a client? Oh, a response. Got it. Which HTTP message would include a status code and which would include an action verb? An action verb would be the request, and the status code would be for the response. What is the name of the additional information that is added to the path of a URL? What's the name of additional information that is added to the path of a URL? The query parameters. I'm pretty sure it's the query. What does MVC stand for? Model View Controller. What is an API? An API is basically a collection of or a software bundle on one server that can be talked to from other computers. What do you need cookies to continue session? Cookie tells the application, the server that you're working with, who you are, so that they can create the session and maintain it. What is the difference between authentication and authorization? Authentication means that you're logged in. Authorizations means can you go to this page or not. Cool. So I think that's good. We're going to mark this one complete and move on to the next one. Thanks for watching, and we'll see you in the next lesson.